For our viscosity project, we decided to focus on a falling sphere viscosity experiment. This experiment focuses on a ball sinking into a liquid. The speed at which the ball sinks in a fluid is directly dependent on the viscosity of the fluid. If the ball is dropped in a viscous liquid, the speed increases at first until the opposing frictional force is as great as the weight force of the ball. Ideally, you should be able to measure how long it takes for the marble to fall and how far it travels and figure out the liquid's viscosity from that. In order to perform this experiment, we needed 4 different liquids, marbles, cups, and a video recording device. We used 4 identical glass cups, 3 marbles, and a smartphone to record the experiment. The marbles were cleaned between liquids when necessary. It's important to note that the temperature at which these experiments were carried out was 67 degrees Fahrenheit. Now onto the liquids we chose for our experiment. This is Kroger brand syrup. This syrup has a viscosity of 2500 millipascals per second, making it our most viscous liquid we chose. This brand is made with lots of corn syrup, which gives it a higher than normal viscosity when compared to other syrups, such as maple syrup. This is Pompeian extra virgin olive oil. This oil has a viscosity of 8.4 millipascals per second, making it our second most viscous liquid we chose. We expected this to have a higher viscosity than we found. This liquid is Woodford Reserve Bourbon Whiskey. This adult beverage has a viscosity of 1.2 millipascals per second, which is nearly identical to water. We expected this fluid to have a higher viscosity than was found based on how it pours into a glass. However, it makes sense given the fact that this was manufactured mostly with corn, yeast, and water. Our final liquid that we chose is tap water. This liquid has a viscosity of 1 millipascals per second, at 67 degrees Fahrenheit or 20 degrees Celsius, which is my room temperature at my apartment. This liquid was chosen as a comparison to the other liquids of our experiment. Now, pay attention to how these liquids are poured into the glasses. The syrup is thick and takes some effort to squeeze out of the bottle. Even as the bottle is placed right up again, some of the syrup stays strapped to the sides of the bottle. Olive oil, our second most viscous liquid, is poured quite easily into the glass, but it sticks to the sides just as easily as the syrup did. The bourbon whiskey, on the other hand, is poured quite easily and doesn't leave any obvious residue once it's sat upright again. Now that we know our liquids, it's time for the experiment. Each glass was filled with exactly half a cup of liquid. With the glass cups ready to go, it was time to race the marbles. Pay attention to the sounds of the marbles hitting the bottom of the glasses as we go from the most viscous to the least viscous liquids. The syrup slowed the marble down, while the other liquids let the marbles fall through. We decided to do this experiment again, but at a closer range to see if the results from the previous experiment would change based on the distance between the drop and the liquid. The results did not vary.